Hello everyone. In this part of video, I am going to discuss about the introduction, generation of harmonics, AC and DC filter. This part will be discussed in this video. So here electrical energy transmitted through AC transmission or DC transmission is to be delivered at the consumer terminals at a specified voltage level of constant magnitude. So our task is consumer should get the constant voltage and constant frequency, so that the appliances used by consumer should not be disturbed. So for that, its voltage level V should be constant. V should be constant, and frequency should also be constant. This should be constant voltage without deviation. The ideal waveform also, ideal waveform means ki our ideal waveform here is sinusoidal waveform, so it should must be maintained, so that the consumer can get a good quality of electricity. The harmonic current generated at the AC bus of a converter get transmitted to AC network and then cause the following adverse effect. If we do not control the harmonic current means ki unwanted wave, whatever our ideal wave is sinusoidal, if it is deviated from it, we have to control it at the AC bus of the converter, because converter generates harmonic, lot of harmonics are generated by the converter. So it should not be get transmitted to the AC network, and if it is transmitted, it will cause the following adverse effect. It must be eliminated in the system, so that adverse effect can be minimized. So what are the adverse effect that we see here? The adverse effect is heating of equipment connected. So the equipment connected will be heat up due to the harmonics current. The equipment connected will be heat up, and this harmonic is generated. There are a lot of sources. Here we are discussing the converter is the source to generate the harmonics. Instability of converter control. So if harmonics is prolonged, then the stability of converter will be also problematic. Another thing is generates telephone and radio interference in the adjacent communication line. This is very important line. It means adjacent communication line. There is a probability that there is a the adjacent system like telephone and communication. This will be affected, and thereby inducing harmonic noise, and harmonic noise will be produced there. Another adverse effect is harmonic can lead to generation of over voltage due to resonance when filter circuit are implied. So due to the resonance, if harmonics can also generate resonance, and this resonance will create a lot of current in the system due to the resonance occurs when inductive reactance is equal to capacitive reactance. This is also occurring because of the generation of the harmonics. Means a time will come when the if we change the frequency, xc is 1 by omega c, and xl is omega into l. So a frequency will occur here, so that the value of the inductive reactance and capacitive reactance becomes same. So at this condition, resonance will occur, which is highly undesirable, and it occurs due to the harmonics in the system. The three distinct sources of harmonic in HVDC system are three distinct, so which is generating this harmonic. The first one is the transformer. Transformer is generating the harmonics in the HVDC system. Another one is AC generator. We will see one by one. And converter along with its control devices. These are the main sources which are responsible for the generation of the harmonics in the HVDC system. We will see one by one. Transformer. In case of transformer, if you see here, transformer also generates a harmonic in the system, and that harmonic in the system is generated. Transformer can be considered as a source of harmonic voltage which arise from magnetic distortion, magnetic saturation due to the presence of DC component in its secondary, in its secondary. So this type of generation of harmonic is caused. So the harmonics by uh, transformer. This is also a source of harmonic, and it is due to the presence of a DC component. It is secondary current. This is the reason. The magnitude of these harmonic depend upon the operating flux density. Operating flux density V. If a flux density is more, then the flux density is more. So depending on the flux density, the the transformer generates harmonics. Converter transformer are usually operated at high flux density than conventional three-phase transformer, and therefore possibility of generation of harmonic is more. If flux density is more, possibility of generation of a harmonic will be also more. Harmonic will be more. Okay, this is all about the harmonic. Other two parameters we will discuss in the next video.